On December 3, 1984, a catastrophic gas leak occurred at the Union Carbide pesticide plant in Bhopal, India, releasing 40 metric tons of methyl isocyanate, MIC, into the atmosphere. This toxic gas exposed hundreds of thousands of people to life-threatening conditions. Officially, 2,153 people died immediately, though some estimates place the toll as high as 16,000. Over 200,000 others were injured, with many left permanently disabled. The disaster caused immeasurable environmental and health damage and is considered the worst industrial accident in history. What happened? On December 2, 1984, at 9 p.m., the MIC plant supervisor was ordered to wash out several pipes running from the phosgene system to the scrubber through the MIC storage tanks. The maintenance department is responsible for inserting the slip bind, a solid disc, into the pipe above the water washing inlet. However, the MIC unit workers were not aware that the installation of these slip blinds is a required safety procedure, and the slip bind was not installed. The temperature of MIC in tanks was between 15 and 20 degrees Celsius. At 11 p.m., workers at the Union Carbide plant in Bhopal observed a rise in pressure from 2 psi to 10 psi in tank 610, which stored 42 metric tons of MIC. This five-fold increase in pressure was dismissed as a faulty gauge because corrosion and poor maintenance made instrument readings unreliable. At 11:30 p.m., workers detected the initial signs of a gas leak, including a yellowish gas cloud and strong chemical odors. The leak was traced to tank 610 but was underestimated in severity. At 12:15 a.m., December 3, 1984, a critical error occurred when water entered tank 610. This likely resulted from routine cleaning of pipelines connected to the tank, during which water passed through a leaking valve. With no slip blinds, metal plates, to isolate the system, water contaminated the highly reactive MIC. The control room operator noticed that control room pressure indicator for tank E610 reads 2530 psi. At 12:30 a.m., a runaway exothermic reaction began. MIC reacts violently with water, releasing heat and generating significant amounts of carbon dioxide. This caused the tank's temperature to soar above 200 degrees Celsius, and pressure skyrocketed to over 55 psi, beyond the tank's design limits. At 12:40 a.m., the safety relief valve of tank 610 burst open. Approximately 40 tons of MIC and other toxic chemicals, including phosgene and hydrogen cyanide, were released into the atmosphere. Early morning hours. The gas spread rapidly, covering an area of 40 square kilometers. Nearby shantytowns were the hardest hit due to their proximity to the plant. People woke up coughing, choking, and with burning eyes as the gas infiltrated their homes. Chaos ensued as thousands fled on foot, bicycles, and any available vehicle, while others collapsed on the streets. Hospitals were overwhelmed with victims, but doctors had no information about the gas or how to treat exposure. Union Carbide provided no immediate assistance, falsely claiming the gas was non-toxic. Failure of safety systems. Vent gas scrubber, designed to neutralize escaping gas with caustic soda, it was offline for maintenance. Flare system, a backup system to burn off gas failed because the connecting pipe was corroded and had not been replaced. Refrigeration system, shut down months earlier to save costs, it allowed the MIC to remain at higher temperatures, accelerating the reaction. Water curtain, the emergency water curtain, meant to contain gas clouds, was ineffective as it only reached 12 to 15 meters, while the gas vented from a 33-meter stack. What are the root causes? Water ingress and MIC reaction. Water contamination initiated a violent reaction in tank 610, causing excessive heat and pressure. Inactive safety systems, the refrigeration system, designed to keep MIC at safe temperatures, had been shut down months earlier. The vent gas scrubber and flare tower were also offline or ineffective. Design and maintenance failures. Carbon steel vent piping was incompatible with MIC, corroding over time and increasing risk. Regular inspections and preventative maintenance were neglected. Management and oversight failures. Poor training and inadequate safety protocols meant workers were ill-prepared to handle such emergencies. Cost-cutting measures led to equipment downgrades, exacerbating risks. Proximity of residential areas. The presence of a densely populated shanty town near the high-risk plant magnified the human toll of the disaster. Key lessons and mitigations. Implement inherently safer designs. Avoid the storage of hazardous intermediates like MIC by adopting alternative manufacturing processes. Upgrade safety systems. Ensure active and robust systems, including refrigeration, vent scrubbers, and flares, are in place and regularly maintained. Improve risk management. Conduct detailed hazard analyses and maintain rigorous inspection schedules for all safety-critical equipment. Enhance worker training, provide comprehensive training on handling hazardous materials and emergency procedures. Land use planning, enforce regulations to maintain a safe distance between industrial facilities and residential areas. Stronger regulatory oversight, governments must mandate stricter safety compliance and hold companies accountable for negligence. Thank you for watching.